Let's talk about vertical asymptotes, more about that. We talked about them in the descriptions or properties of rational functions. Now we're going to talk about vertical asymptotes in terms of calculating them. So how to find the vertical asymptote of a rational function. Factor the numerator and denominator. Note any restrictions in the domain of the function. Reduce the expression by canceling common factors in the numerator and denominator. Note any values that cause the denominator to be 0 in this simplified version. So as we talked about in the last problem, the x plus 3's would divide out, so that would not create a vertical asymptote. But the x minus 3 would, as we saw in the little drawing I did. So, okay, these are the vertical asymptotes where they occur. Note any restrictions in the domain where asymptotes do not occur. These are removable discontinuities. So in this example, so we have k of x equals 5 plus 2x squared over, and this would factor to be 2, I want to say 2 minus x times 1 plus x. Because that gives me 2, oh wait, one's got to be negative. No, that's positive 2. Then I have a, no, oh, I got that backwards. So I think it's a 2 plus x times 1 minus x. Let me just check. 2 times 1 is 2. 2 times negative x is negative 2x. X times 1 is positive x. That gives us our negative x. And then x times negative x is negative x squared. Okay. So the numerator is not going to factor at all. That's prime. So we could take 2 plus x, set it equal to 0, and x equals negative 2 is going to be an asymptote, a vertical asymptote. And then 1 minus x equals 0. So let's see, subtracting 1, negative x equals negative 1, and divided by negative 1, x equals 1. So our vertical asymptotes are at x equals 1 and x equals negative 2.